Good afternoon, all. Today I am going to explain about our project. Our project is Alzheimer's disease detection using Ensemble machine learning approach. Coming to the introduction, firstly, Alzheimer's disease is nothing but memory loss. It is a very dangerous disease and the symptoms develop as age passes. To predict the existence of this disease, we use machine learning techniques like support vector machine, ADA boost and neural networks. In this project, we first train the machine learning classifiers and then use the remaining data to test the model. Coming to the proposed system for this model, the system includes a feature selection technique called NCAF, also known as Neighborhood Component Analysis and Correlation Based Filtration, which select cognitive features from given dataset. And also various machine learning classifiers are trained like SVM, Random Forest, ADA Boost using NCAF method, and the top classifiers are selected on based on voting technique on based on the performance using an adaptive weight matrix process. Using this method gives us an advantage of combining several base models to construct one optimal model. Coming to the methodology, for this project, the follow is first data exploration is done, then the processing where data will be ready for processing. Now, splitting of data for training and testing is done. After the training of machine learning classifier is done, finally web application is designed and tested. Coming to the dataset and feature selecting, the dataset is taken from ADNI, AD Neuroimaging Initiative. This dataset contains different records like cognitive normal and Alzheimer data disease record in this dataset. However, the dataset has many missing values and contain irrelevant features. So first, the dataset is taken and then data pre-processing is done where the missing data handling is done, where the data gets normalized, and then this data is sent for NCAF testing, which is data analysis. Now coming to the adaptive ensemble learning model. The model which we used contains many machine learning classifiers like decision tree, random forest, k nearest neighbors, logistic regression, deep neural networks, ADA boost, voting classifier, CNN plus LSTM, and tracking classifier. We will see one by one. This is the ensemble machine learning model chart. First, the importation of packages is done where the packages are imported using import function. Then the exploring of the dataset is done using exploring function, where the dataset processing is done. The pandas data frame is taken and dropping unwanted columns, like removing the unwanted and missing values. Now the visualization is done using visualization function and label encoding is done using label function. Now this data is again coming into training and testing. For training, the data is taken here, and for training we use all the classifiers, we train all the classifiers, and then for testing we created the web application. In the web application you need to first sign up, and then you need to give the input, and then we can predict the output. This is the data chart for this project. Coming to the decision tree. Decision tree is a supervised machine learning algorithm which is best suited for classification regression problems. In decision tree, we have common splitting criteria like entropy, information gain, or mean square error values. So now coming to random forest. A random forest is an ensemble linking machine which combines multiple decision trees. So multiple individual decision trees are taken and all the decision trees are combined to form a random forest. Coming to the k nearest neighbor. K represents the number of nearest neighbor considered when making a prediction of classification. So this is also based on like voting system. See, here is the data point. There is category A and category B. It checks the distance between this point and this point. Where the nearest point is located, it goes toward that category. So coming to the logistic regression. Logistic regression is a supervised learning technique which is used to predicting the category dependent variable given using a given set of independent variables. So it is taken between given independent variable the values which maximum prediction and minimum prediction 0 and 1 for this logistic regression. Coming to deep neural network, a deep neural network is a type of artificial network with multiple layers as input and output layers. In the ADA boost technique, it takes an adaptive boosting is an ensemble machine learning technique used in machine learning for classification and regression tasks. ADA boost works by iterative training a series of weak learners on the same dataset. So first it trains the dataset and then it classifies into different parts. Coming to the CNN learning model. CNN automatically learn hierarchical features from input data, making them effective for complex tasks. So that's why we use CNN for classification. So now this is new technique, CNN plus LSTM model, where we have integration of both CNN and LSTM taken. Advantage of this model is capturing both spatial and temporal dependencies through end-to-end integration, which also help us to reduce complexity and provide task-specific adaptability. Stacking machine learning model. Stacking is an ensemble method that combines the prediction of multiple base models using a higher level model to make the final prediction. Advantages of stacking over voting are: stacking goes beyond majority voting by learning how to combine the base models optimally, which gives us more flexibility and adaptability in combining models. So the results in conclusion for all the datasets are taken. Here are the classifiers which are being used, and we have compared with use of accuracy, precision, recall and F1 score. So we have compared for all products for KN and the accuracy, precision, recall and F1 score. After comparison, we have found that for stacking classifier, it is better than any other classifier considered. So stacking classifier is giving us more predictive of AD. So this is how we create a website. So first, for a web application, we need to go. This is the home screen which we have created, and this is the user login. You can sign up here, and then you can, after signing up, you need to give your username and password. Then you can type the input in this, and then you will get the result predicted. So this is the this is the results in conclusion. This is the classification performance for all the graph based on their accuracy, precision, F1 score and recall score. This is the visualization graphs. So for comparison, stacking classifier has more than any other classifier found in for all the 4 points. Thank you.